Welcome to Object-Oriented Programming 1. Is it loud enough? Can you hear me all? Bit louder, okay. Maybe it's now better? Yeah, okay. Okay, welcome to Object-Oriented Programming 1. Today we start with the practicals for about 1 hour and 15 minutes, and then afterwards the lecture will continue. Of course, I'm not alone today. Again, Julia is with me. Recording is also started, so you can see everything also later if you want to. So let's have a look on what we're doing today. First, we will start with a recap from the last lecture, where we had this introduction to C++. Then we will continue with a very small part, which we were missing last time, which is handling the input in C++. Then we will do what we will usually do in these practicals. We will do some live coding. And afterwards, Julia will show you how to handle multiple files in C++. And if we have enough time at the very end, we will also discuss the make files very briefly. Okay, then we start with the recap from the last time.
Okay, so last time we first heard about references, and I hope you all remember. So we said they're a bit like pointers. And as you can see here, we can create a variable a with the value 5, and then create a second variable, which is now a reference to this variable a. And if you now just assign a value to b, a gets changed to. We can run that. Yeah, we see this is 10 now. So you see this is really just like pointers, except that you don't have to dereference anything. It just works.
So like A and B are more or less the same variable. So if we change them, both change. So we have two names for the same variable here.
Okay, then we also heard about vectors and the for each loop. With vectors, we can more or less create arrays, which can be dynamically resized without us having to do memory management. Here I'm creating this vector. We specify the type, the variables in this vector between these angle brackets. So here we create a vector of integers. And then with this range-based for loop, we can just iterate over the whole vector without having to do anything with its size or creating an iterator variable. We just always have the current value we are iterating over in this I variable and can then print it out. We can also look at that. Yes, and this works. Yes?
Will the value in I be copied?
Yes, so this here, we just set auto, so it's the same as if we said int, and the value is just copied to I.
So you could also do int end, so int reference. And
Yes, we'll come to that later. Okay, so, and we also talked about strings, which have similar operations than vectors in C++. And here I just have a quick example to show you how you can create a string, append one character, and then print it to standard out. Okay, so I think that's everything we did last time. Are there any questions to that? Yeah?
does it also work if you write auto reference?
Yes.
But you're spoiling a bit our example now that we've prepared for later, so but no problem. One more question? Yeah?
Someone asked a question, could you repeat it? Because if someone asked the question, it's very hard to understand.
Yes, you're completely right. And we also should do this for the recording. So we will think about this from now on.
Mm-hmm.
Okay. Then we come to the part that we were missing last time, so we didn't manage to finish with that in time, so we go through it now. We have seen last time when we want to output something in C++, we were using stdcout instead of printf. And now we want to have a look on how to handle inputs in C++. And like the direct inverse operation to cout is the cin operation. So we create here, for example, an integer, and then we call stdcin, and we have those two greater signs, and then the variable. And stdcin means we're now expecting an input, and we want to store that input in the number here. And then we can, again, with the cout and the two smaller signs, output something. So here you can also see when we're using cout, we have these left arrows, and when we have an input, we have these right arrows. So they are like the inverse operations here. So that's the way how we can store something in a number. Maybe to discuss this a bit more, this stdcin is very similar to scanf. And of course, we had some problem in scanf. Probably most of you experienced that probably in an assignment in Introduction to Structured Programming, because you were expecting that an integer is entered, but you entered an empty space or some character, and at this point your program crashed or ended up in an infinite loop. So also here we have this problem that we really require that the expected type is here. So if we go back, here we really need that an integer is entered, and if a string is entered, then okay, we have a problem. And now the alternative to that is the getLine function. That's something that was not present in C, and with this, no, it was present in C, with the fgets function, and getLine is now very similar. We call it in the following way. It has 3 parameters. This will be the file stream. In our case, this would be then cin. Then a string. So we have a C++ string instead of a C string here. And delim, whatever delim is. So let's have a look. So we read here from cin in the string until a delimiter is found. So a delimiter is a character where we want to stop reading. So if I would specify as a delimiter an empty space, then we would just read the first word. Or if we specify in the delimiter the new line character, then we would read the whole line and store it into the string. And yeah, last time we also discussed in context of functions default parameters. This delimiter has a default parameter, which is this new line character. So if you just call getLine with stdcin and a string, then it will just read one line and stops at the first new line character.
And now you might already see one difference to fgets, because you don't need to specify any length, because a string can have any size, so you don't have to handle these cases.
So you don't have to call stdgetLine repeatedly like you did it with fgets. Just call it once and everything else is done by C++ already. I think I also have an example here. Yeah, exactly. So we create here a string which we call line, and then we call the getLine function based on stdcin. So we really want to read something from the command line and specify the string where we want to store it. So this would be the line here, and afterwards we can also output the entered user input again. So this would be getLine, and now we extended the input a little bit. So we prepared one more slide here.
Okay, so in C++, files just work the same way as if you would read from cin. So we have this stdif stream. So this is an input stream. That's what the I is for, where you can open more or less like cin a stream to a file. You can check if this file was really opened by calling the isOpen function, and you should always do that. That's like checking for null in C.
So if you call fopen in C and then check for null, exactly.
And then you can use getLine or these write errors to read from this stream like you would read from cin. And another benefit, the file is automatically closed when this input stream object goes out of scope. So you don't have to handle these cases.
So you cannot forget to call
Yeah.
fclose at the very end.
I also have an example for that. I create this if stream here, call it file, and I pass this parameter, which is just a file we have in this directory. And if it's not open, we return -1. So we just return some value to indicate that we have an error here. Then I create this string to read one line into, and I call getLine, pass as a first parameter now not stdcin, but the file I just opened. And then I pass the line. Now I can print this line, and just for demonstration purposes, I'll now also use these write errors to read one line from the file. And I'll print this too. We can run this, and we see apparently the first 2 lines in our git ignore file are these 2 values.
And also again here, if you're using the double write errors for the input, so the second last line, and if you do not specify a string, but an integer, for example, then you really need an integer in the file that it can be stored there. Otherwise, you have to do some error handling. So probably, usually it's better that you call really getLine, get a string, and then work with the string and parse the string instead of using the cin directly. And we have one voluntary exercise that we wanted to give you last time, but we didn't make it at the very end. So I'll give it now to you, and I think it's also a good preparation for assignment 1. So if you want to have a short head start for assignment 1, then you can already do this and then use it in assignment 1. And everything we have discussed so far is contained in that exercise when you do not need anything else. So just read a line from cin, then split the string into words or parameters, and the parameters are separated by spaces. So last time we had this string split function, substring function, find function, so you can use them here. And then store all these words in a vector. Last time we discussed the vector, and it consists now of strings, and then use the for each loop to print the vector. Yeah, and a small hint, this is something that you will use in assignment 1, so maybe you can do this already and you have a head start for assignment 1. Okay, now we come to the live coding. Would you like to present what we're doing in the live coding?
Yeah. Do we have slides?
Yeah, we have a slide there.
Okay, so in the live coding, we just want to read one line and then replace all empty spaces with underscores and then print a modified string again. So I think this should be easy enough, but we're using many new features from C++, so you can now really see how these all work together, similar to your homework.
Maybe the first bullet point is now also the first task of your voluntary exercise. So, okay, then let's start. There was a question.
Okay, so the question was if we want now to replace the spaces in the existing string or if we want to create a new one. In this example, we'll just replace the spaces in the string.
Yeah, exactly. So, one more question? No, okay. I think it's you to start.
Okay, so at the start, we just have this hello world program. Yeah, and we can try this out. We already heard last time that we're now using Clang++ to compile our program. Yeah. Then we can specify the file. Right now it's called main.cpp and specify where we want to save the binary to. And if we compile this now, we can run it and see that this Hello World program works.
Okay, now the first thing that we want to do was to read a line. So that's what we want to do now. So we need to create a string first. So we create a string, I don't know, input. And to use the string, we of course need the corresponding include, which would be include string. And now I should switch off Copilot probably, that not everything is spoiled. And now we had those two options to read something from std_in, and we're using now getLine. So we specify std getLine. From where do we want to read? From cin. We store it into the input. We do not need to specify the delimiter because it should be a line, and the default value is the new line character. And afterwards, we can also print the input. And now let's see whether that works. So compiling, executing. This is my input. And we outputted also, this is my input. And I think we do not need the hello world anymore. Okay, now you have your input.
Okay, now we want to iterate through this string and replace all spaces. So we'll use the new for each loop, where we just specify some variable, then have the colon, and specify this, the thing we want to iterate over. So in this case, it's our string. We can iterate, for example, over string, over vectors, over many types. Okay, and now let's check if the current char we are reading is a space. And if it's a space, I want to replace it with an underscore. Okay, then
Probably copy the print down that we also see the output.
okay. So, do you think that this will work now? Okay, can you explain why you think that?
Because you can just like copy the character in the C variable, but you're not like trying to change the character itself without a user reference.
Okay, so she said that right now we are just copying the character into the C and we are assigning to it, but this won't change anything in the string.
So basically the C would be now just a copy of the value which stands in the input.
Yeah, let's try this. And yes, nothing changes. So
how can we
should
repair
fix
that?
that.
Yeah. Do you have an idea for that?
yeah, as it was,
Was some knocking? Yeah. We can use an and symbol.
yes.
Maybe you can show us this.
We can use this ampersand to specify that here we have a reference now. And if we assign to a reference, we're really changing the variable it references. So let's try this again. And yes, now it works.
So basically we have now this character C and the value at, for example, position 0 in the string, and they are just aliases, so they are really the same variable behind. And that's why it works now. And yeah, last time we also have seen a cool new feature with this auto, where we do not specify the type of the variable, but you can use auto instead. And we can also observe here the same behavior. So if you're just writing auto here, then the C is just again a character as before. And if we run the program, I need to specify the input, then we do not have the underscores, because again, we just got copies. And also with auto, we can specify that it's, We also can specify that you have the reference, and now this C is really a character reference as before, and if we test it again, then we also get the expected output. So now we have the underscores again. So this really also works with auto, that you can specify a reference there.
Okay, so now we want to write a function where we're replacing spaces in a string, because we want to have everything in a function. So let's just write one. Then pass the string. And now let's just copy the for loop into the function. And call it here. Okay. Do you think this works? Okay. Does anyone know why this might not work? Yeah? Okay, so we pass a copy of the string to this function. And yeah, this is correct.
So maybe we also try it again and prove that it doesn't work. Yeah, and we see it doesn't work, even though we have specified the reference here. How can we fix this now?
Yes, so we also need to specify a reference, of course, up there in the parameters when we pass the input.
Okay, so we have to specify the reference here. And is it now correct just to pass the input to the function, or do I need to modify this as if I would pass a pointer to the function?
Yeah, so here you can just write the input, because if a function takes a reference and you pass it a variable, it automatically gets a reference to this variable. We already saw that in getLine, because there we just specify the string and it just changes it, so this works.
Okay, then let's test it one last time.
Last time, when we talked about this, we talked in the context about vectors. So if you pass a vector to a function, really everything in this vector is copied. And that's the same for strings, of course. So if you pass this input there, the whole string is copied when you call a function.
Okay, I think that was the whole example. Do you have any questions, or should we apply any modifications to the code that you're interested in? Or is everything so clear so far? Yeah? Mm-hmm. So the question was, if we want to store the string with the replaced characters in a new string, how to do that? So one option would be, of course, that we just copy the string and then change the copy of it. This would be an option. We could also, of course, iterate through the first string and always append to an empty string. And also in this case, we would get the second string and we would append a modified character if we have the empty space here.
Yeah, but probably the best option would just be to copy the input down here and then pass the new string to this function.
Any further questions? Yeah?
And the question was why we don't use namespace std in this code. We covered that last lecture. The reason was if you just use the whole namespace std, there could be some naming collisions if you want to create a function and accidentally the same function exists anywhere in the whole namespace std that you have included, then you'll get an error. But of course you could say something like using std : cin, and then you will just use cin
C in you said.
Or a string.
I'm sorry.
Yeah.
And now we can write C in here instead.
Yes, so this would be the much better option. Yeah?
Can you comma separate them? So to say using standard in, comma, standard out, comma, standard C, is that possible?
We will just
don't know.
try it. Does it compile? No, it's not allowed in the C standard, apparently. So you get the warning in this case. So we really need to write them one by one.
Okay.
Any further questions? Yeah? Did you get that?
So I think the question was if we are using this here, if this only works in the main or if this would also work up here? Okay. I'm also not sure.
No, I don't think it works. We're using here now the string. You should use both of them probably. STD string. So now we have the string from starting here down below, and now we remove the STD string here, and let's see whether it works. No, it doesn't work. So really, if you're using the using statement, then down below it works, but not above. Does this answer your question? Okay.
Yeah.
Okay, then.
Okay, then
We continue, I think. So now we'll have seen some code. Now we'll do a short different part, and we will discuss about what you need for the practicals. Probably most of you already know this from ESP, but nevertheless, we need to talk about it. But maybe you can use the time already to log into Menti in the time we talk about this, because then we have a short Menti quiz about some basics you should also know from Introduction to Structured Programming. So we give you 20 seconds, then we switch to the next slide. And okay. So before we start with the quiz, what do you need to know, and what tools do you need for the practicals? You probably need a virtual machine, or you have native Linux installed in dual boot setup, for example, the VSL, Windows Subsystem for Linux, or usually macOS also works.
Yeah, so we now have the test runner for Linux and macOS, both ARM and x86. Linux often works better because there are some things that often go wrong on macOS, but yeah.
And we probably missed to give you the link to the virtual machine, so if you want to download it, you can find now the link in the Teach Center for both versions of it, for the x86 and the ARM version.
Is this still the same as from ESP?
So
Yes.
the question was, is it the same virtual machine as from ESP? Yes, this is true.
If you want to find the guide for the setup of the virtual machine, it's still in the Introduction to Structured Programming course website.
And if you're on Notion, I just linked it today. So here in our Notion, you have to set up your device, and this goes to all the instructions regarding Git, virtual machine, and so on. So what else do you need in the practicals? Probably an editor. In the virtual machine,
We already have one.
VS Codium
Yes.
is pre-installed. Of course, you can use any that you like, for example, CLion or whatever you want. And one more important thing, you need a GitLab account. So if you have not attended Introduction to Structured Programming, please log in on gitlab.thgraz.at at least once, such that we can create a repository for you. Yeah?
So if I
You can always use the VM to make sure that everything's the same, like on our side. But if you already have Linux installed, this should be enough. And you can also always check the test cases online on GitLab. Then you can be sure that everything works.
Any further question regarding these tools? Okay, then I hope everyone already logged in to our quiz. You can find the code up there if you want to join.
Yeah.
Okay, then let's start with the first question.
Yes, so the first question is how would you, so in Bash on Linux, create a directory named OOP1 and then change to that directory?
Probably the options are on your smartphone better visible than here. Okay.
Yes.
So the options were touch OP1 and change directory OP1, but touch would create I shouldn't say that.
No.
I shouldn't say that. So make directory OP1 is the correct thing. So make directory creates really the directory, and cd OP1 change directory changes to this directory.
So these questions just really are about some basic stuff.
And most of you knew it, so very nice. So next slide. Okay. So now there's the question how to create a file named main.cpp. I hope that everyone has this question now correct. Not everyone has the question correct, although I spoiled it on the question before. So if you're using touch, then you create a file, and everything else are creations from our side. So only touch is a valid Linux command here, and touch main cpp creates that file.
Okay, so the next question is, how do we delete this file now? So we have rm, remove, del, and rm file. Yeah, so most of you got that correct. rm deletes a file. I'm very happy to see that you still know your Linux basics.
I think we have 2 more questions. Or 1 more question.
This now might be a bit more complicated.
Okay, now we have the output of git status, and we want to write the output of git status directly into a file, which is called test.txt. Okay. So it was kind of that some of you already saw the result before? Okay. But can you explain what the correct answer was at least?
Yes, so it's just this larger than symbol here, which we can use to redirect the output of the git status command to a file. This would redirect the test file to the input of the git status command. And yes, the other ones you can look up yourself.
Maybe this is also helpful if you test your program and you don't want to, so you have really large output that you can pipe it then into a file and then look at the output afterwards so that you don't lose it in a command line, for example.
Or you could create a file which already has all your input you want to send to your program and then just use this symbol to pipe this into your program. So you don't have to test some functionality, always write the same stuff.
So this is quite helpful. And now a last question that hopefully works better than the question before. Okay, give it some time. So what is the output of this code snippet? So we have some vector here of type integer. Does it not work? Does it not work correctly? Yeah, but I don't know why this is the case. So we're very sorry that the quiz didn't work that way, that we intended to work, because we would like that everyone could answer, but I don't know why this happened. Maybe we have to do something else than Menti the next time. But at least maybe we can explain why 000 is the output here. So this was the code again. So we have this vector and iterate over the vector. And now we have this auto I here, which is just a copy of the elements in the vector. So we just change the copy to I. And this means in the vector afterwards, we still have those 3 zeros stored. And when we output those 3 zeros, then these are the 3 zeros in the very end. And
So-
for that reason, nothing changes.
Yeah. So auto is here always just a type, and auto never really becomes a reference. And if you want auto to be a reference, you have to specify that. Okay, then now let's continue with multiple files in C++. You need this for the assignment. So how can we split up our code into multiple files? And for that, we are using header files. So you already know include. And header files are used to share declarations of functions or constants between files. And you can include them with this include statement. But if you want to include a file which you created yourself, you have to put it in quotation marks instead of these angle brackets you're used to from a standard library. And for these header files, you create these .hbb files. And yeah, header files only contain declarations most often and no definitions. Yeah, let's look how do we compile multiple files. When we compile, we only specify the CPP files. So most often for each CPP file we have, we create exactly one header file, which we'll include in other files. And to compile these, we'll need to specify all CPP files to Clang. Yeah, like this. Or if you just want to compile all CPP file, you can use this wildcard here.
So with this star operation, you really include every CPP file there. So even if there are multiple CPP files, but you do not want to have all of them compiled, it would take everything. So if you really need to specify certain CPP files, then you have to write them explicitly there.
Yes, and with this note here, I just mean that you only need to specify the CPP files to Clang. Then now let's look at an example. Okay, so let's look at our example we had before. We want to split this up into multiple files. So let's create a replace string.cpp file. And now we also need a header file. So we'll create an HPP file. Okay, so what do we need? Well, first, let's just copy our function into this new CPP file. And we'll need to include the corresponding header file here. Okay, and now in the main, let's include the replace string header file. But what do we need to write into this header file? Well, what you will always need are header guards. We'll come to why you need them soon.
So this is basically a template which you would need to use in every header file?
Yes. You always need to use those. I'll come to why later. So, and now in this header file, let's just copy this. We just have the declaration of this function. And I think we need to include string. So in the header file, we just have this declaration, so the function prototype, and in the CPP file, we define the function. It's very important that the prototype always matches to the actual definition of the function, else it won't work. And then in the main file, if we include this header file, then we can use this function. Yes? Yes, I'll come to that later. So, what does this include actually do? Well, this include tells the preprocessor to just copy this file we specified here into this one. So what it will do is it will take everything from here and just copy it into the main function, like this. And now we have this declaration of the function already in the main. And if we compile the main.cpp file and the replace string file, we can see that this works with just the prototype here. And this is just the same. We can see this also compiles and we can run it. Yes, and it replaces the spaces. Yes, so all we are doing here is copying this header file into the main, and this header file just tells the compiler that somewhere else we have this function.
I have a question. What would happen if we do not compile both CPP files, but just the main?
Yes, we can try that, but we'll get an error. So if we just compile main.cpp, we just get this error that we have an undefined reference to replace string. So actually it did compile, just the linker failed. And this is because in here we are saying, okay, this function exists, but then it actually doesn't. And then we get an error.
So it does not find like the code that is behind the function. So it doesn't know what to execute when this function is called.
Can you link both C++ and C into one executable?
Yes, but you will have, I don't think it's trivial. You have to do some stuff.
Any further questions regarding multiple files?
Yes? No. So pragma1 is actually not a C standard, but just a common extension to the compiler. So you should actually use these header guards. But I will get to this now. So what are these header guards? If header files are included multiple times, this can lead to errors if you have some conflicting definitions, like if you have some loop in your includes, the compiler can't resolve that if you allow it to include it multiple times. And the solution are these header guards. So this now might seem complicated, but I think I'll just demonstrate it. Yes. So, if we omit these header guards and compile now, okay, we didn't specify the replace. Okay, it works because this file is just copied in here and there's no reason it shouldn't work. But if we have something, for example, some other header file, I'll call it loop.hpp, and I'll include the replace string here, and then in the replace string header file, I'll include the loop header file. And here, for example, we could just have some constant, which is some value. And if we try to compile this now, we see that we actually get an error. And we see this very long message where it tries to include those files. And this is, well, let's just look at it. We include this replace string.hpp file. So maybe we can just do this. This is copied here. And then here it tries to include the loop.hpp file. So this file, more or less, is copied here. And then it tries to include the replace string file again. And you may already see that this leads to an infinite loop, because now we include the loop header file again, which includes the replace string header file again, and so on. And this is what we see here.
So this is this infinite loop where they include each other and it never ends because every file includes the other file and so on and so forth. So do the header guards fix now this problem?
Let's check.
This is probably also important. different header files need to have different defines here. So they need to have different names here. Otherwise, the same constant would be defined and it wouldn't work. So really, each header file needs a different name here, and it's very common that you just use the name of the header file as this constant in the include guards.
And if we compile now, it works. And it just gets included once. If we, yes?
Can you maybe show replace string CPP for again for a second?
Here we just include the header file.
So it's basically the same as in the main CPP.
Yes.
It
And we
works.
also don't need to include the string library because we also already are including it here. Maybe let's see how these include guards work. If we copy this here now, we can see here we check if this constant is not already defined, and it's not. So we define it here. We declare this function, include loop. Loop is included. This constant is also not defined, and we define it. And then when we here include replace string again, in this check here, we see, okay, this constant is already defined. So we just skip all of this because up until here, everything is in this if. And loop won't be included again, and we don't have this loop.
So you just copied now the replace string HPP, and now it would still copy the loop, right? Over
Yes.
into the main, okay?
Oops.
Maybe you can demonstrate that.
So we copied this loop. And then here, when you have this replace string,
It would also be copied, right?
yes, it would also be copied, but replace string is already defined. And we can see that VS Code already grays out this code. And this is because here we have the if. This n is for not. So if this is not defined, we want this code to be here. But it's already defined because we have this defined up here. And so we just skip it and it doesn't get included again.
So this really prevents this endless loop that we've seen before. I think that was everything that you prepared, right? Are there questions regarding that? This is like really important because you will use multiple files for every assignment in our course.
Yes?
So predefined, so hashtag defines are global over all files.
Yes. Yeah. They are...
Yeah, I mean, it really depends. So basically in this construction that we have before, those defines were then copied into a file. And in this file, they were used.
They are valid for each compilation unit. So for every thing you compile. And if you compile multiple CPP files and have a define in one, this just is for this one file. But you can also specify for the compiler that you want to define something, and then it's defined for every file. Yeah. Okay, and yeah?
I didn't quite get the difference between HPP and CPP files. So could I also have put this loop where I change the symbols into the HPP file? Or why does it have to be a separate CPP file for the function?
So the function, the question is, why is there a separate HPP file, and what's the difference between an HPP and a CPP file? These header files are just there so you can compile multiple of these files like here. So you compile multiple smaller units and then compile them together or link them together. And the difference is that with these header files, it's more or less just convention that in the header files you just have these prototypes where you just specify which functions there are, and then in these CPP files you actually implement them. It's okay if you don't fully understand why you need to do it this way, but yeah, please use a header file and a CPP file. Yes, and if you didn't quite get that, why we need these header guards, that's also okay. Just use them, or else you will at some point get an error, and maybe also deductions.
Maybe also one more motivation why you should separate those HPP files and CPP files. Now assume that we do not have just a very short replace string function, but assume that we have a really large project that's behind this replace string function, that's really doing a lot of things. So, for example, we would have, I don't know, 10,000 lines of code in this CPP file. And we really want to avoid that the CPP file has then to be compiled every time the way we use this code. So the separation is really important because we can now compile the CPP file. We have the header file, and it's just enough to include now the header file instead of the whole code in our main, and then we can just compile the main, link it together with the replace string, and
which is already compiled.
Which is already pre-compiled. We don't show this how this works, but we can pre-compile that, and then this large function does not need to be compiled. So, for example, think about a function or a library think about the standard library. If you would need to compile the whole standard library every time you compile a CPP project, this would really need a long time. And that is why you always include the header files only into the from the standard library. For example, the vector, for example, the string, IO stream, whatever. And then this provides you with the definitions that gives you the interface that you know which functions exist. Then you can use the functions, but the code behind the functions is in separate CPP files that were already pre-compiled that you do not have to compile on your own.
Mm-hmm.
Is it possible to say #include replace string CPP? So can you include the CPP?
So the question is if it's possible to include a CPP file. Yes, I think this should be possible, but please don't do it.
So basically file names do not matter, but you should use the correct file names always.
This include is really from the preprocessor which copies code around before compiling.
There was another question somewhere up there.
In the replace CPP file more functions, not just replace string. When I write it in the HTTP file replacing, can I call more than one function, or is it just one function?
So the question was, if you have multiple functions in a CPP file, can you specify that in the HPP file? And yes, of course. So if we have a second function here, with, I don't know, just some test function, we can just specify a second function, implement it in the CPP file, and this will also work.
But of course, you can also intentionally omit functions in the HPP file that should not be called from outside of the CPP file. If you have just a helper function, for example, that would do this job, and you don't want somebody to call the function, then you just omit it in the HPP file, and then it's just internally usable in the CPP file. I'm sorry? Auslassen. I think there was one more question.
So the question was, if you had a third CPP file, do you need another header file? And yes, you should do this. So for each CPP file you have, you should create a separate header file.
Any further questions?
Should the header file always be named the same as the corresponding CPP file? Or how does the compiler even know where the definitions of the function prototypes are?
Okay, so there were two questions. First, if the header file should be named the same as the CPP files, and you don't have to do this, but you should do this. I don't know if it's in the coding standard, but please do this. This just makes everyone's life easier if you know this header file belongs to this CPP file. And the second question was, how does the compiler know if you can include an HPP file in which CPP file the function is? And it doesn't really need to know this. It compiles each CPP file on its own and then later links this together in one big binary. And then at the end, it just has to exist. Yeah.
So, for example, if you could just compile the main CPP without the replace string.cpp.
Like we did before.
We got an error, but you could just compile it until the last step is happening. So just compilation, not linking. So you basically compile it. And then this replace string is not required that you have really the definition of the function. However, once you have multiple compiled files and you want to create an executable out of this, then every function must be defined. And in particular, this means that this replace string function must be defined in some file that you're using. It must have been compiled already in some file. And only in this last step of the compilation phase, this is important. And if this is not the case, then you get an error and you get not an executable file out of it.
Yes, so compiling and linking is really a complicated topic.
One more question up here. I'm sorry, can you be a bit more quiet, please, because we cannot understand the questions otherwise. Okay, so the question was whether we need to declare the classes in header files. So
Or struct.
we keep it with structs now. Classes will be the topic in a few minutes. So if you create a struct, then you usually create the struct in the header file. And if you would then have some functions that use the struct, then you would, of course, define them in the CPP file. And why is that? Again, because you want to have the struct definition or declaration in for every CPP file that you're using, and that's why you have it in the HPP file, such that you can always include it.
Yes, if you declare a function in a header file, then the compiler knows, okay, this function exists. But if you wouldn't write the struct into the header file, the compiler has no idea what this is you wrote there. So yes, it needs to go into the header file. Okay.
I think, well,
yes.
Why does the include string have to be in the .hpp file and not in the CPP file where the function is?
You can include the string also in the CPP file, but we are using it here, and therefore we need it in the header file.
okay, I think then we continue with the last topic in this. Yeah. Okay, one last question here.
Yes, so the question was, if you create in another file a constant with the same name, then you should get an error. You should get an error because you can't define two constants with the same name. But there are also ways to then reference to exactly this constant in another file, but this is a topic for some other time.
Okay, then we continue with our last topic for today, and we have a short look on makefiles, because you were already using them in Introduction to Structured Programming, and now this whole compilation thing gets a bit more, it's a bit larger because we have to specify multiple files, and now we want to implement a way to automate the whole thing, and that's why we use the makefile. And the makefile really offers a lot of opportunities. So if you want to have some details there, you have to look that up. We will just cover the most basic thing here, and this is the syntax of the makefile. You specify a target, that is what you want to do with some automation. Then
So the name, more or less.
the name, yeah? Then you have some dependencies, so what you need for this target that it can be completed, and a list of commands that need to be executed. So, for instance, the target could be the main without an ending, so the object file that we created, the executable. The dependencies would then be the files that need to be compiled, and the command would then be the Clang++ and so on. But let's have a look on that. So we create here now the makefile, and I open it. And for our simple project, we now want to write this makefile. And the first thing that we want to do is we want to compile our project. And we always named the output main, so we also do this here. So we specify the target name. This is the executable main. It depends on some things. We will just skip this here now. Then I do an indentation with a tab. Yeah, so it's not enough to have spaces here. We really need the tab here. And then we can compile. And in this case, we call, for example, Clang++. The output file should be main, and we need to compile main.cpp and replace string.cpp. Maybe we do it this way. Okay, and now if I run make main, I probably need to remove first make main. Then we see, okay, this Clang command was executed immediately. If I run it again, we see, okay, there is some problem because main is already up to date. And why does this happen? Because this main file already exists. So because we already specified how this binary should be named, it already exists, so it doesn't update. And now the dependencies are the important thing. We write now a list of dependencies. On what does the main file depend? On main.cpp, on replace string.cpp, and it depends whether it's done or not, but I will also specify now the HBP files here, because it really, the whole project depends on all those on all those files. Now, if I run it again, okay, again, nothing happens. So it seems that nothing changes, but that's not true, because if I go now to the main CPP file and change it, and if I run now make main again, then the make file was so clever that it sees that the main.cpp changed after this main, the executable, was created, and that's why this Clang command is executed again. So if we do not specify these dependencies here, then if the main file exists, it doesn't compile anymore. But now we really specified on which files it depends, and if there is a change in some of these files later, then this main, the executable was created, then the makefile is so clever that it really compiles it again. Now we can introduce more commands to the makefile. For example, we could specify a run command, and again, the indentation with the tab, and just executes the main file. So in this case, this run command does not need to match a file name that we have. If we call make run, then okay, it runs our program and we can input something. Very nice. I will remove now the executable and make run again. And now it doesn't find, or it doesn't run the program because this executable doesn't exist. And this is also something that we can automate now, because we can right now as a dependency for the run command that the main needs to be created. So we write here main. And this means, okay, when we want to run, then we need to check first whether this main exists. And this main specify now this command here. And if the main is not up to date, or it does not even exist, then we do the compilation. So try it again. We call make run. And now we see that 2 commands were executed. First, this clang command for compilation. And then afterwards, so this was this dependency, and then the run command with the execution of the main. Doesn't matter. And if we run now the make run command again, then only the main is executed, because everything here was up to date, nothing changed in between. So makefile is again smart enough that it doesn't compile, but it just immediately runs it. And now we can even specify more commands. One example would be that we, for example, make a clean command that removes the main file. We can also call make clean here, and then the main file, the file is removed. So if we want to execute it, we see there's nothing. We can call make run again, it compiles it again and runs the program then. So you can really use those makefiles to automate your compilation process, that you do not need to write all those CPP files all the time, and this maybe makes your life a bit easier. Just one remark on the makefiles we are using, they are even a bit more clever than this simple makefile that I showed you, because they compile all CPP files separately. So if you're interested in that, then just have a look in the assignment 1 repository in 1 week, how this makefile is structured, but it's a bit more complicated. So we just keep with the simple version of the makefile. Not sure what I have. Okay, this was just the example.
Then maybe let's look at the Menti quiz. Who won that?
Oh, we need to look at the Menti quiz still. But of course, it's a bit biased now because it didn't work the way we wanted it to work. And Bingo is our winner.
Congratulations.
Is he or she here? Okay, here in the second row. Very nice. Okay, so we really finished now on time. I need now to mention, I'm not sure whether this is really the case, because the aerospace team, is there somebody here of the aerospace team? They will give you a very brief introduction to their student team, and then we have a short break and the lecture will start at 5:30.